Good evening everyone. Today we are going to do the daily Leetcode challenge of 22nd January 2023. That is question number 131, Palindrome Partitioning. So this week Leetcode challenges are all about backtracking. And if you have watched the previous videos, this question will be very easy for you. So the question is saying that you are given a string S and we have to partition S such that every substring of the partition is a palindrome. Return all possible partitioning of S. What is a palindrome? A palindrome is a string that reads same forward and backward. And let's move on to the examples and understand it better. Okay, so for give you an example, I can tell you, suppose there is a word called Nitin. It is read forward and backward same. When I write it backward, it is also Nitin, so the word remains same. So that is an example of palindrome. So let's see the example here given and understand it better. Here we are given what? We are given AAB, and we have to return all possible partitioning of palindrome. We have to create palindromes and combine the combinations which we can get. So we are having AAB. We can partition it. When we partition A, we are getting A. When we partition this A, we are getting A, and when we partition this, we are getting B. So these single string elements are a palindrome in themselves. Yes or no? So that is our first answer. And next option is, when we partition it from here, we are getting A and we are getting B. So A is same and it is a palindrome, and B is also a palindrome, so it is our second option. So how do we approach to these options? How do we get the intuition? The first thing I told you in the recursion videos, whenever we have to return all possible palindromes or all possible substrings or all possible subsequences or all possible subarrays, then we have to think around recursion or backtracking. So this is the same concept we are going to use here. So now move on to, now I will give you an example how is backtracking applied here. So when you see this question, you can see that we have two choices, whether we will partition it here, whether it will be the part of partition and palindrome, or whether it will be a part of partition but not a palindrome. So we do not include this. Okay, so this is how we have to think. So let's move on to the example. Suppose we are given AAB. When we make a partition here, let's start by one step. We are getting A and we are getting AB. So at every step we will check whether it is a palindrome or not, and we will create a current and we will store our A there. We will store our palindrome there. So A is a palindrome, so we will store it. After that, our index is here and we have to think whether we can partition it here. Yes, we can partition it here. So we have A, and we have B. So we will add this A to this current and our current will become A comma A. And after that we will partition the B. Then we will get AAB. So when the current is ended and we have no more to go further, our current is completed. That is, current becomes AAB, and we get our palindrome. So we push this current into a result vector. So it is pushed into a result. So this is the first step you have to do. And when you call back or backtrack the function, you are popping the current. You will pop the elements from it. And when you move on to the right chain, then again you push the answers in the current. So why didn't we move this side, sir? Because when we partition it from here, we are getting A and AB. And is AB a palindrome? No. So we will check for the palindrome at every step. And if it is not a palindrome, we will not move further. This is our condition. So that's why we didn't move this side. Now let's consider we made a partition here. So we will get AA and we will get B. So our current is now empty because we popped it when we was backtracking. So now it will push AA to our answer. So currently current is having AA. And when we make a partition here B, we will get B and A. So A is a one palindrome and B is another palindrome which will be pushed here. So what we are getting, then again we will backtrack and we will remove the elements. And before removing the elements, we will push it to a result. So that's how we are getting a result vector. So the main thing to keep in mind here is we are checking for the palindrome before partitioning. We will only make the partition if it is a palindrome and we are checking for it. Yes or no? That's how you approach this question and you backtrack and you solve this. To brief you with the overall approach, what we are doing, we are creating a current vector, we are creating a result vector. We will make the partition, we will check whether it is a palindrome or not. And if it is not a palindrome, we will not divide. If it is a palindrome, we will divide. And when we reach the end of the string, we will push our current into the result. Why we will push the current into a result? Because we are sure that whenever we are partitioning, it is a palindrome. So we can push it to our answer. And that's how we are applying backtracking and solving this question. So let's move on to the code, and let me just zoom it for you. So to start with the coding part, let us create some global variables. We will create a n, which will give us the size of the string. We can write it as s dot length or s dot size to give the size of the string. We will create a vector of vector string to store our result answer. Why a vector of vector? Because inside a vector we are storing vectors. That's why we are creating vector of vector string. And let's name it as result, as I told you in the explanation. Also, we need a vector string to store our current variables or current string. This current string will be stored here. And when we pop back, we will make it empty and add another current string, and then we will push it to the result. We will see how that is working. And what I told you for the backtrack remains same. For backtrack, we pass the current string, we pass the starting index. We also need to pass the current and result, but we have declared them globally, so we do not need to pass them again. And by passing, we always pass by reference to avoid creation of copies and increasing our time and space complexity. And when this all is done, we will return our result. That's what we have to do. So let's just create a backtrack function. So in our backtrack function, what we are passing this string s, and we pass it by reference to avoid any creation of copies, and we pass our starting index. Now, what will be our base condition? Our base condition will be when our index is equal to the length of the string. Then we will stop and we will write some conditions here. But before that, what I told you, we will simply run a loop for int I is equal to index I less than n I plus plus. And what are we going to do? We will check if is palindrome, whether it is a palindrome or not. How do we check it is a palindrome? We will pass the string, we will pass the left coordinate, and we will pass the right coordinate. Left coordinate will become index, starting coordinate, and ending coordinates will become I. So that's how you are checking is palindrome. We will complete the is palindrome function later on. But now write what is happening if it is a palindrome. If it is a palindrome, what I told you, we will push it to our current. Yes or no? So we will push the current substring to our current. How do we push a substring to a vector? So for that we use s dot substring sub str. This is the inbuilt function which will create a substring for you, where you have to pass the starting index and the ending index. How can you pass the ending index? In Java you can directly pass the ending index, but for here you have to provide the size, and that size will be I minus idx plus 1. I hope you know this. Now when we are done with the current push, when we have pushed it to our answer, when we have pushed this, what we are going to do? We are going to backtrack. We are going to backtrack with I plus 1 index. And when all this is done and when we reach the end, we are going to pop back. Yes or no? So we are going to pop back current dot pop back. And ultimately when we reach the end, what the condition is happening? When we reach the end of the string, what we have to do? We have to push. What we have to push? We have to push our current to the result. And when we have pushed the current to the result, we will return. Yes or no? Now when this all steps are done, we just need to complete our is palindrome function. So for that we will write bool is palindrome. And palindrome function is very simple. You have to check the left and right, the ending and starting points, and keep on checking until they are different. If they are different, you will return false. What I mean by that is we will pass the string by reference here again. We will pass the integer left, we will pass the integer right. Left denotes the starting coordinates and R denotes the ending coordinates. And we will start a simple two-pointer approach. When left is less than right, what we will do? We will check if SL is not equal to SR. At any moment, if it is not equal, that means it is not a palindrome. So we will return false. And if this is not the case, we will simply increase our left and we will decrease our right. So what is happening here? So what I mean is left coordinate is here and right coordinate is here. We are checking whether they are equal or not. When they are equal, we move on to the next one. And that is how you are iterating to check whether it is a palindrome or not. And when this is all is done and we did not return false, we will return true. So this is all you have to do. So let me just run it and check whether it is working or not. What we wrote vector, and yeah, it is accepted. So let's just submit it and check whether it is accepted or not. And yeah, it is accepted. So to brief you with the question overall again, what we had to do, we have to return the partitions, palindrome partition. So we simply applied the backtrack, and for applying backtrack, we checked whether it is a palindrome or not. So what are the total time complexity of this question? What will be the total time complexity? So we have two choices for every element, whether to include it partition or not, include partition or not, include partition or not. So in the worst case, we are having, if there are n elements, we are having two choices for every element and it would be 2 to the power n. And as we have to check for the palindrome as well, so it will become 2 power n into n. So this will be our time and space complexity, because when you are calling backtrack and recursion, you are creating a stack, let's say. So that stack will be storing this much of value. And we have created some constant vectors to store the answer as well. So the time and space complexity will be 2 power n into n. I hope you understood the question. If you have doubt at any step, please let me know in the comment section. Thank you so much for watching. Please like, share and subscribe. Bye bye.